Gateway was an interesting concept in 2017 when we weren't faced with a Chinese rival that could potentially beat us back to the moon.
In a pretty rare moment, lawmakers and NASA leadership came together to discuss the president's budget request for the agency. Normally, these meetings can get a bit dry, but this one actually covered a lot of important stuff about NASA's future on the moon. We're talking about things like building lunar infrastructure, whether the Lunar Gateway is finally being phased out, and a whole lot more. So here are some of the key takeaways. First, let's talk about the Lunar Gateway, because its current situation has just been revealed to be even worse than we thought. In the meeting, Isaacman basically made the case that building a station in lunar orbit just isn't as compelling anymore. The real goal, according to him, is to be on the moon itself, where the scientists, engineers, astronauts, and honestly, most space fans actually want to be. He described the Gateway as an interesting concept back in 2017, but said it doesn't really make sense today, especially with the growing competition from China. Instead of orbiting the moon and looking down, the focus is now on actually building something on the surface. This shift is already leading to some pretty concrete changes. NASA has canceled parts of the Gateway program, including the Habitat and Logistics Outpost. So, for those who might not know, the Habitation and Logistics Outpost was designed to be a pressurized living and working space for astronauts. It would have supported a crew of 4 for missions lasting at least 30 days, while also handling command and control operations. On top of that, it included docking ports so other spacecraft could attach. At the same time, not all the hardware is being scrapped. Some of it is getting a new role. Take the power and propulsion element, for example. It was originally designed as a solar electric propulsion system for the Lunar Gateway, based on technology developed at Jet Propulsion Laboratory during the now-canceled Asteroid Redirect mission. The idea was for it to generate power using large solar arrays and use ion thrusters for efficient propulsion, basically keeping the station in orbit and even acting like a space tug for visiting spacecraft. But now, instead of heading to lunar orbit, the PPE is expected to be repurposed for a new nuclear power and propulsion demonstration mission, often referred to as SR-1 Freedom. Jared Isaacman also pointed out a pretty serious issue. Both of the Lunar Gateway's habitable modules, including the Habitation and Logistics Outpost and the IHAB, were found to have corrosion problems. And honestly, that alone could have pushed the station's timeline well into the 2030s, even if there hadn't been any policy changes. So personally, I think canceling the Lunar Gateway is a pretty reasonable call. It frees up NASA to focus on things that actually get humans onto the moon faster. And according to Jared Isaacman, stepping away from the Gateway should definitely help speed things up. One of the big issues he pointed out is launch cadence. After Artemis 1 flew in late 2022, the next launch didn't happen until 2026, and that kind of gap just doesn't work for a system as complex as the Space Launch System. With so many contractors involved and hardware based on older designs, you really need frequent launches to stay sharp and build experience. So the plan now is to pick up the pace starting around 2027, with the goal of having key infrastructure like power systems, communications, and rovers ready by the time astronauts land in 2028. The bigger idea here is to get back to something closer to the Apollo era mindset. Launch more often, learn faster, and rebuild that muscle memory. Instead of waiting years between major missions, NASA wants to test things step by step, starting in low Earth orbit, where it's much safer and easier to recover if something goes wrong, before committing to a full lunar landing. The goal is to be ready for multiple landing attempts in 2028, which boosts the chances of success. As Isaacman put it, the objective is pretty simple. Be on the moon, not just orbiting it, and do it before the competition gets there. Then NASA can move on to the next big step, building out real infrastructure on the moon. Now, it might not sound as exciting as landing astronauts, but this is actually where things start to get serious. If you want a long-term presence, infrastructure is everything. The goal here is to support a crewed base near the moon's south pole, shifting the focus from just orbiting the moon to actually living and working on its surface. For getting around, NASA is working on lunar terrain vehicles. Instead of relying on one super expensive rover, the plan now is to build multiple vehicles with different industry partners. That way, there's redundancy, both for crewed and uncrewed missions. Interestingly, the first few rovers will probably look pretty similar to the ones from the Apollo era, And honestly, that's fine. We haven't driven on the moon in decades, so starting simple and learning as we go makes a lot of sense before moving on to more advanced designs. Another really cool concept is the moon hopper drones being developed by Jet Propulsion Laboratory. These are autonomous vehicles designed to help build the base and move scientific payloads around. They're inspired by the Ingenuity helicopter on Mars, but instead of rotors, they use small rocket thrusters to hop across the surface, potentially traveling up to 50 kilometers in a single jump. Power is a huge challenge on the moon, especially during the long lunar night. That's where fission surface power comes in. It's considered essential for running equipment, supporting astronauts, and enabling things like resource extraction. NASA is aiming to have working surface power systems by around 2030. There's also the Harmonia project, which focuses on using americium-based radioisotope systems to keep equipment warm and operational through extreme cold. This is a big deal because surviving the lunar night has always been one of the toughest technical challenges. And then there's SR-1 Freedom, a nuclear power and propulsion demo that repurposes hardware from earlier programs to help establish nuclear capabilities in space. To tie everything together, NASA is building out LunaNet, basically the moon's version of the internet and GPS combined. It'll handle communications, positioning, navigation, and timing for everything from astronauts to robotic systems. Early phases of the base will involve testing different communication methods, both on the surface and in orbit, to figure out what works best in the lunar environment. Of course, none of this matters without places for astronauts to live. The plan includes building surface habitation modules to support a long-term human presence. This shift also comes after issues with earlier Gateway hardware, like the Habitation and Logistics Outpost, which had corrosion problems and helped push NASA toward focusing more on surface systems instead. Another key piece is in situ resource utilization, or ISRU. The idea is to use materials already on the moon, like ice or regolith, to produce things like fuel, water, or building materials. Long-term, this could even lead to a kind of lunar economy. There's also basic surface prep to think about, things like landing pads and roads. It might sound simple, but preparing the terrain will make landing safer and rover travel much easier. To support all of this, NASA plans to standardize the Space Launch System and increase how often it flies. The Orion will be the main vehicle for bringing astronauts back from the moon, tying the whole system together. Honestly, one of the biggest takeaways from all of this is how strongly Jared Isaacman called out what he sees as decades of mismanagement and cost overruns at NASA. He pointed to several troubled programs to back that up. For example, a 2025 report from the Government Accountability Office found around $15 billion in cost overruns across major NASA projects since 2009. The Mobile Launcher 2, which originally had a contract value of $383 million, is now expected to cost closer to $1.8 billion. And the Space Launch System Block 1B upgrade alone is projected to hit about $5.7 billion. Because of that, Isaacman laid out some pretty clear priorities in the proposed fiscal year 2027 budget. Get astronauts back to the lunar surface by 2028. Build out a moon base with help from industry, and transition toward commercial space stations by around 2030. That said, not everyone is on board. Several lawmakers pushed back hard, especially over the billions being cut from NASA's science programs. Critics argue that those cuts could seriously hurt important research and weaken the agency's long-term mission. Isaacman acknowledged those concerns, but his argument is pretty straightforward. If you spread funding across too many programs, nothing really moves forward. His view is that focusing resources on a few key goals is the better way to actually get results.
To win, we cannot establish programs that are designed to be too big to fail, but at the same time, too costly to succeed. Nor should it be throwing more money at the problem, but rather fixing the problems and concentrating resources on the mission and delivering outcomes.
While there are a ton of exciting things NASA could be doing in space, the reality is you can't do everything at once. So focusing on the moon program for now, and actually getting it done on time, isn't a bad strategy at all. What do you think about this strategy? Let us know in the comments. All right, let's wrap things up with some rocket news, because this one's pretty exciting. This is one of those rockets that doesn't launch very often, but when it does, it's always a spectacle. Yep. We're talking about the Falcon Heavy. A Falcon Heavy launch is scheduled in just a few days, currently targeting April 27, 2026, with a launch window around 9:21 to 10:46 Central Time, 14:21 to 15:46 UTC, and a backup opportunity on April 28th. This mission will carry the Viasat 3F3 satellite, which is the third and final spacecraft in Viasat's trio of high-capacity Ka-band satellites. It'll be heading to geosynchronous transfer orbit after lifting off from Launch Complex 39A in Florida. As for the rocket itself, the center core is expected to be expended this time, meaning it won't be recovered. But the two side boosters are planned to return and land back on Earth, touching down at landing zones 2 and 4. What makes this launch even more interesting is that it'll be the first Falcon Heavy flight since 2024, marking the 12th mission overall. There's been a bit of a gap since its last major flight, like the Europa Clipper launch, so it's great to see this rocket back in action. After this mission, the next flights that really need the power of the Falcon Heavy are already lined up, and they're coming up pretty soon. One of the big ones is the Nancy Grace Roman Space Telescope, currently targeted for late 2026. NASA has confirmed Falcon Heavy for this launch, and the mission will focus on studying dark energy and searching for exoplanets. Then, looking a bit further ahead, in 2028, Falcon Heavy is also set to launch the Rosalind Franklin rover for the European Space Agency. This rover is designed to search for signs of life on Mars by drilling up to 2 meters beneath the surface, deeper than any rover has gone before. So yeah, even though Falcon Heavy doesn't fly that often, when it does, it's worth watching.